Hello again, it's Asala, and today this video is going to be about manifolds. So let's get into that right now. A manifold is a topological space that locally resembles an Euclidean space near each point. More precisely, each point of an n-dimensional manifold has a neighborhood that is homomorphic to the Euclidean space of dimension n. Now, I'm pretty sure that was a big mouthful of huge words that you probably do not know, but I'm about to teach you those. Now, let's start off the Euclidean space. Euclidean space is a two or more dimensional space. It is used to denote the position of an element in the system of two or more dimensions. Let's also define homeomorphism. It is the correspondence between two figures or surfaces or other geometrical objects, defined by a one-to-one mapping that is continuous in both directions. This is an example of homeomorphism. A donut is being transformed into a coffee cup step by step. So we basically covered what a manifold is. Let's look at some examples of them. These are examples of a few manifolds: a sphere, torus, double torus, cross surface, and clean bottle. Let's explain these. Let's start with the most commonly known one, called the sphere. Now, a sphere is an object that is completely round and shaped like a ball. Pretty simple, right? Almost everyone knows what a sphere is. So let's get into the other things. Let's get into the torus. It is a surface or solid formed by rotating a closed curve, especially a circle, around a line that lies in the same plane but does not intersect it. There is an amount of real-life example of toruses, such as donuts, life buoys, and O-rings. So let's move on. Now, let's discuss the next thing, the double torus. The torus, as you can see, is a surface formed by the connected sum of two tori. We earlier went over the single torus. This is basically two single toruses joined together. Now let's get into the cross section. The cross-section or cross cap is the self-insertion of a one-sided surface. The cross cap can be thought of as the object produced by puncturing a surface a single time, adding two zips around the puncture in the same direction, then to distort the hole so that the zips line up, requiring that the surface intersects itself, then zipping up. So that's basically what makes the creation of the cross cap, or cross-section. Oh, I should probably add something about the cross cap, because you see, it is also a continuous image of a Mobius strip that intersects itself into an interval. Now, the reason we mentioned that is because I want to talk about the Mobius strip, which is one of my favorite things, and one of my favorite manifolds, because I think it's really interesting. This here is the Mobius strip, and I'm about to explain it to you. The Mobius strip is a one-sided, non-orientable surface obtained by cutting a closed bend into a single strip, giving one of the two ends thus produce a half twist, and then reattaching the two ends. That's how one is made. Now, one of my other favorite things about the Mobius strip is the kind of reverse or mirror effect it has. Let me explain. An object that existed in the Mobius strip shaped universe would be indistinguishable from its own mirror image. Now, let me explain exactly what that means. Do you see this crab on the Mobius strip? Well, with every circulation on the Mobius strip, its claw will switch from right to the left side. That's what it means when I say it has kind of a mirrored effect. That's why I like the Mobius strip, because with each circulation you go in reverse. And the truth is, this is only a non-orientable or a one-sided object. It has no other sides. Yet, the more you move around it, the more you reverse. Next is the clean bottle. The clean bottle is a closed, non-orientable surface of either characteristic 0 that has no inside or outside. It can be constructed by gluing both pairs of opposite edges of a rectangle together and giving one pair a half twist.